have talked a little bit about forces in equilibrium. It is now time to talk about study examples. How this forces in equilibrium is applicable in our daily life. So, I've written study examples. We are going definitely to discuss about two examples, and they are here. I've written one of them is here. Our question is, a uniform metal loop is pivoted at its center. In learning forces in equilibrium, every statement has got its meaning. Now, it is something very important to understand every statement with its meaning. A uniform metal loop. Why is it called a uniform metal loop? Not only a uniform metal loop, something uniform. It is something of that equal things. Uniform, just like this. This is a rod. Why is it uniform? It is uniform because the diameter here is equal to the diameter here. It is width and its thickness does not vary. It is the same at every point. And that's why we say this is uniform. If you find somewhere thick and somewhere thinner, that is not uniform. Including my body. My body is not uniform. Because somewhere thicker, somewhere thinner. Now, say something uniform, that it is uniform in every point. And its dimensions is the same at every point. Now, when I say uniform metal loop, means my metal loop is uniform. Example of a metal loop, this is a metal loop. Why it is called a metal loop? It is a ruler with 1 meter. If it is a ruler of 1 meter, means it is a ruler of 100 centimeter. Why? Because 1 meter is equal to 100 centimeter. And that's why it is called a meter loop. And therefore, we say a uniform metal loop is pivoted at its center. A uniform metal loop. Now we can draw. This is a uniform metal loop. Now if here it is 0, here it is 100. Because we have said a metal loop is a meter with 1 meter with 100 centimeter. And that's why I have said 0 to 100 centimeter. But it is pivoted at its center. The center of 100, it is a midpoint. A midpoint of 100 is at 50 mark. Now it is pivoted at its center. Means the length from one side to the pivot and the length from the other side to the pivot are equal. Why? That's why we say pivoted at its center. Now here we have 50 centimeter on this side, and this we have 50 centimeter on this side. And that's why we say it is pivoted at its center. Now we are talking about the first statements. A uniform metal loop is pivoted at its center. Means the center now is the point of pivotation. It is where the ruler is pivoted. Now 50 centimeter. Now the second statement is at 20 gram mass. A 20 gram mass is placed at 10 centimeter mark. Now we have something mark. Mark is always at the point where there is 10 centimeter. Now, if here now is 0 and here it is 100, don't expect that you will find 10 centimeter in the other side. You will find it here. Because from here to here is 50. Now, 10 centimeters is around here. 10 centimeter mark. There is a difference between 10 centimeter mark and 10 centimeter from the axis of rotation. When somebody says that this is 10 centimeter from the pivot, now you measure that 10 centimeter from the pivot to where you want to stretch a mass. If it is the right or the left hand side of the pivot, you have to do so. But now here it is 10 centimeter mark. Now imagine now your ruler measure here it is 10. Now the mass of 20 gram. Now from here up to here 10 centimeter was placed. Now you can define whether you hang it or you place it on the top, no matter how the situation is. But what matters, now you have placed 10 centimeter mark. That is what the second statement. A 20 gram of mass is placed at 10 centimeter mark. And 50 gram mass at the 40 centimeter mark. Now the other point that we're talking about, it is the mark. 40 mark. Now 40 mark, remember from here up to here is 50. Now we're still on this side because 40 centimeters around here. Now the other mass, let's say we have placed it here. This is the 50 gram. Means from here up to here is 40 centimeter mark. Now the question is, at what mark must a second 50 gram? Means the other 50 gram. Where will you put that other 50 gram? In order for the rotation back, in order for the system to be a rotational balance, in order for the system to balance, where will you put this 50 centimeter mark, gram? It is a simple question that you would have said in this case. Placing the other 50 gram, it won't be in this side. It must be in this side, in order for it to balance. Because when you keep on placing on the other side, you won't balance it. And therefore, what makes it, we must place the other 50 gram on the other side in order to make it balance. Because that is what we have been told, for the system to be in rotational balance. You won't balance it if you keep on placing on the other side, on the same side. You must place it on the second side to make it balance. Now the other 50 gram is placed on the other side, which is 50 gram. Is placed on the other side. Are we together? But what is the problem here? We don't know at what mark. We don't know the distance where this mass of the second 50 gram will be placed. We only know that it will be placed on the second side because we just want to make it balance. So definitely it is something that you need to understand. Now we are through about diagram. But this doesn't make us now we are through about the question. Let me show you experiment and what we're talking about here. I said this is the uniform, this is the uniform, this is the uniform. Both of them are uniform, but this is the rod. But this, let's assume this is a metal rule. Do you understand? To know where the center of this, if the body is uniform, to know where the center is, you don't need to use much energy. The same applies to this one. I want to know where the center of this rod. Very simple. Now, when I place here and somewhere balances, that is where the center of that rod. Because mass of an object of a uniform body is said to be concentrated at its center of mass. And we say center of mass is the point where the mass of an object is said to be concentrated. For the uniform. And that's why you can see it is balanced. Because I have chosen the center of mass. If the uniform body is pivoted at its center, it is mass won't produce what we call it moment. Why? Because moment of the force we have said is equal to force times what? Distance. Force is produced by the mass of an object. But distance is the distance from the axis of rotation to where the mass is placed. But remember here, the distance is at the same point and where the mass is there. Now the distance is 0 from the axis of rotation. Now if the distance is 0, now 0 times any distance. I mean, the force is there, but distance is 0. No matter what kind of the force are you talking, any number multiplied by 0 is what? 0. Now, any uniform bond, if it is pivoted at its center, it won't produce what we call it moments. And that is why here we didn't discuss about the mass of the ruler, because it was pivoted at its center. As you can see here, it is balanced. Now, even if you take your ruler and then start determining the length from here to here, it will be very simple. You will find it from here to here is equal to from here to here. They are equal. Now the same applied, then if you want to determine this one. Now look at here, balance. Now you start putting those things. Let's assume this is the mass of 20 gram, and this is the mass of 50 gram, and this is the other mass of 50 gram. Now the mass of 20 gram, we've been told it is placed 10 centimeter. Let us assume here it is 10 centimeter. Here it is 10 centimeter. If I leave or I withdraw my hand from here, this ruler will fall this way because this mass is there. Now that's why I am supporting it. Now the other mass of 50 gram is placed 40 centimeter. From here up to here. Let's say 40 centimeters in here. Where if the second 50 mass will be placed, the second 50 gram will be placed on the other side. For the system to be rotational balance, must be placed on the second part. Because if I place it here, it won't balance. It will definitely fall to the other side. Now, the question is, at what mark Now let us keep on trying until it balances. Now it is balanced. So we were trying to look at what mark we balance. Now the distance from here up to here is 10 centimeters. The distance from here up to here is 40 centimeters. But what is the distance from here up to here? If now we would have found now we are doing the experiment, we would have taken a rule and measured from here up to here. Very simple. We've been told the distance from the 20 mark is 10. And the distance from, 50 grams is what? 40. And this is by what that it is center. Now, what is the distance of the second 50 grams will be placed? Simple now. You start measuring. You use a ruler. You measure distance from here up to here. How much is? But there we have no practical. We are doing mathematical. There is something that exists. Now we are looking for the distance from here up to here. The only thing that you have to understand, back to the question now. We have 10 centimeters, we have 40 centimeters. We have distance from the axis of rotation to where the second mass is placed, which now let's say it is y. It is what? Y. This is according to Newton's law. The Newton's first law says that for every body continues in a state of rest or uniform motion, provided there is no force opposing it to change that state. And that's why this will stay here forever, the day tomorrow and the day to come, if there is no external force causing it to move. Kwa hiyo taiacha hapa na itaishi hivi milele kama hakutakuwepo na nguvu yoyote inayosababisha kiharibike. Now from here you are not supposed to use direct lens. Don't use them. Please, I beg of you, don't use them. The only distance that we deal when solving these questions is the distance from the axis of rotation. The distance from pivot is the distance that definitely we deal. Kwa hiyo hatushughuliki na hizi, tunashughulika na umbali. How far is an object from the pivot? The distance from the pivot where the second 50 grams is y. We don't know it. And now we want to know it. But the distance from this pivot to where the first 50 grams we can determine. And the distance from the pivot to where this 20 grams we can determine. Why? Is this simple to determine? It is simple because we have 10 centimeters, we have 40 centimeters. Now what is the distance from the axis of rotation to where the mass of 10 grams? From here up to here, 10 centimeters. But if from here up to here is 50 centimeters. Now what is the distance from here up to here? Taking that 50 minus 10. You get what? 40. Now 40 centimeters is the distance from the pivot to where 20 grams is placed. But also the distance from the pivot to where the mass is placed, 40 centimeters. But from here where the pivot is placed, 50 centimeters. Now the distance from here to here is 10 centimeters. Now the distance from the axis of rotation to where the mass is placed is 10 centimeters. Sio kwamba nimechanganya, kwamba nabadilisha hii na kuja hapa na hii. Don't confuse. It is not all about interchanging. I have done mathematical. That is what which happens that case. But the distance from here up to here is 50. Now we have this. After that one, now we have this one. This mass 20 grams pivot. Then you have the second mass of 50 grams. The distance from here is the y. And also the distance from here to here. We have said it is 40 centimeters. And then we have the other mass, the other 50 grams. The distance from the axis of rotation from the pivot. Now it is 10 centimeters. Now in short, these are a distance that is we are going to deal with when solving this question. And not this one, not this 10, not this 40. We use this 10 from the axis of rotation, 40 from the axis of rotation, and y from the axis of rotation. We have something called clockwise and anti-clockwise moments. These are forces. The force due to 50 grams and the force due to 20 grams. These are forces. This force will cause an object to rotate in this way. Now you can see here. These forces will cause an object to rotate in this way. But these forces, this force, it will cause an object to rotate in this way. We get it? Now, if I would have stand here, we say this will cause an object to rotate in this way. We have two things here to discuss. One is here, the second is here. This we call it rotation, and this is also rotation. This, and this. We have those things. Let me talk a little bit about those things. We have clockwise and anti-clockwise rotation. We say we have anti-clockwise rotation and clockwise rotation. The direction of rotation is the best described using the terms clockwise and anti-clockwise. Clockwise, that is positive, and clockwise that is negative, and clockwise is positive. This is the negative. This is the positive. This is the anti-clockwise, and this is the clockwise. Now, 50 grams will produce, and this will produce. Now, those are the things. Now, from here, we have simple things. We have two alternatives. According to the principle of moment, clockwise moments is equal to the sum of anticlockwise moments. Clockwise moments is equal to the sum of anticlockwise moments are equal to the sum of clockwise moments. Means what? Moment that will stand on this side, no matter how many are they, and moment which will stand on this side, no matter how many are they, are equal. Now the first alternative, which is simple one, and we call it a shortcut. It is taking now this time this one. Now it is 40 grams times 20 grams times 40 centimeter. Plus the other one is 50 grams times 10 centimeter. Will it be equal to 50 grams times y? Now we are looking for the value of y. This is a algebraic expression. Now, collecting the like terms, 20 times 40, we get 800 plus 500. Now these are gram centimeter. All both of them are what? Gram centimeter. Is equal now to 50 gram y. Now we have 800 plus 500. We have 1/3. Gram centimeter is equal now to 50 gram centimeter. Gram y, sorry. Gram what? Y. Now let us divide by 50 gram. Divide by 50 gram here. Now y is equal, now this cancels by 0, 0. By 5, 1. By 5 here, it is 2, 6. Now y is equal to 26 centimeters. I have made this possible because of applying the principle of moment. Sum of anti-clockwise moment are equal to the sum of clockwise moment. And that's why I've made it happen. Now, no matter how many are there, we have 50 times 10 plus 20 times 4 is equal now to 50 times y. Y is equal because the sum of clockwise moment are equal to the sum of anti-clockwise moment. No matter whether here you have placed 10 of them, but what matters, on the second also you must place the man that will definitely balance both of them. Now, this 26 centimeter is from here up to here. Now, the second 50 gram is placed on 26 centimeter from the pivot. Now here it is 26 centimeter from the pivot. Now from here up to here is 26. But remember, from here up to here is 50. Now 50 plus 26, 50 plus 26. Now it is 76 centimeter mark. This is mark. But 26 from pivot. Now if now somebody asks me, the distance from the pivot, you say 26 centimeter from the pivot. But the distance, the mark, where the mass is placed, you say, is equal to 76 centimeter mark. Alternative, the diagram is the same. Do you understand? Okay. If you think this will be simple to you, it's a point to you. If now you think the other case that we have used is simple to you, a point to you also. Keep on trying until you grasp it. Now, We convert this gram into forces. Simple. Let's start with the clockwise forces. Anti-clockwise moments. Now, anti-clockwise moment for 50 grams from F is equal to mg. Now, mass is 50 grams, but must be converted to what? To kilogram. You divide it by 1,000, and then it becomes what? 0.05 kilogram. But G, remember G is equal to 10 Newton per kilogram. Then we are looking for a force. Now force is equal to mass, which is 0.05 times 10, which now is equal to 0.5 Newton. Now force for this one, force for 50 grams is equal to 0.5 Newton. But the distance is 10 centimeter. Our distance is equal to 10 centimeter. But the SI unit of distance is not in centimeter. It's what? Meter. Now let us convert this centimeter into meter. Now definitely we find it is what? 10 divided by 100. You get it is 0.1 meter. Is it so? Yes. Now a moment, because we have moment for 50 grams is given as force times what? Distance. Force now is 0.5. Distance now it is 0.1. If now you multiply them, you definitely force times distance, you get 0.05 Newton meter. This is the moment for 50 grams. Then for 20 grams, which now is approximated to 0.02 kilogram. And distance also is equal to 40 centimeter, which now is approximated to 0.4 meter. Now let us calculate force. Now force is equal to mg. Now mass 0.02 times 10g, 10, which now is equal to 0.2 Newton. Then from moment is equal to force times what? Now force is 0.2. Distance now is 0.4. Now is equal to 0.08 Newton meter. Because now these are on the same place, are on the same side. Means we calculate, we sum them, we put them together and we call them the sum of anti-clockwise moment. Anti-clockwise moment is equal now to 0.08 plus now 0.05. When you sum them, you find it is 0.113. Now the sum of anti-clockwise moments are 0.13 Newton meter. Now let us talk about clockwise. Now clockwise moment, we have only 50 grams. We can convert it into what? Kilogram. Definitely 0.05 kilogram. Now let us find the force for this one. Now the force for that one is equal to mg. Now mass is 0.05 times 10. We definitely now we get it is what? 0.5 Newton. This is force. Now if now force is equal to 0.5 Newton, but we are not looking for a force. We are looking for the what? Moments. Now moment from here, moment of 50 grams. Distance now is equal to 1. Now moment is equal to force times what? Distance. But force is 0.5 times distance is y. Now it's equal to 0.5 y. Now the sum of clockwise moments is equal now to 0.5 y. But now from here what we have seen the sum of anti-clockwise moments is equal to 0.13 Newton meter. And there we have seen the sum of clockwise moment is equal to 0.5. Now from the principal moment, the sum means sum of anti-clockwise moment is equal to the sum of clockwise moment. The sum of anticlockwise moment we have seen it is 0.13. Is equal to the sum of clockwise moment is equal to 0.51. Now we are looking for the value of y. Now the value of y, we divide by 0.5, we divide by 0.5. Now y is equal now to 13 divided by 50, which now is equal to 0.26 meter. Now the y distance is 0.26 meter. Remember why I have written meter? Because we were converting centimeter into meter. And that's why what we have got here, it is 0.26 meter. Now, if nowadays you need to convert this one into centimeter, remember the relationship that exists between the meter and centimeter. 1 meter is equal to 100 centimeter. Now, definitely we have to multiply by 100. Then y is equal now to 26 centimeter. The same way and how we did. Now, it is 26 centimeter from the pivot. Or it is 76 centimeter mark. So this is the thing that we have done. Now, you choose. You have option. Whether converting them into forces, which is the correct way. A correct way is converting them into Newton. Because moment deals with the forces. Or solving them directly. Also, it is a correct way. Thank you. Now, let's talk about the next question. Now, after we have seen the first question, now let's see the second question. This is an example. A uniform rod with a mass of 120 gram and a length of 130 centimeter is suspended by a wire from a point 80 centimeter from the load's left end. A uniform rod. A uniform what? Rod. A rod which is uniform. As I said before, if it is uniform, now this is a rod. This is a uniform rod. The rod is 120 gram and the length is 130 centimeter. Now this is lefty rod. Lefty, it is lefty side of the rod. And this is the right side of the rod. Now, from here, this is 0. Up to here, the length, it is 130 centimeter. But its mass is 120 gram. The mass of the uniform rod is concentrated at its center. Now, when you look at here, the mass of 120 gram is hung at its center. Now, the center of 130 is 60. Now, this 120 is hung because the mass of the rod, uniform rod, is suspended at its midpoint. Because the mass of an object is already concentrated at its center. And that's why now we have placed 120 at its center. Means from here up to here, 65. From here up to here, it is 65. Now that is the first statement. But it is suspended. It is suspended by a wire from point of 80 centimeter from the load's left end. From the load's left end to where the 80 centimeter, there is a wire. This is a wire. Let's imagine from here up to here is 80 centimeter. Now, it is suspended by the wire. Now, this wire acts as an axis of rotation. Or it is acts as pivot. It's suspended by a wire from a point of 80 centimeter from the load's left end. Now, from here up to here, 80 centimeter. From here up to here, 65 centimeter. Now we have here 65 centimeter. Then from here, 80 centimeter to here. Now this is the wire. It is suspended by the wire. Means it attached to the wire. Hanging. What mass must be hung from the right end? The right end is here. Now what mass must be hung here? The mass that must hang here is X. It is unknown. And that is the need of the question. What mass must be hung from the right end of the rod for it to be in equilibrium. For it to be in equilibrium, what mass must be hung here? Now we have to consider this is the axis of rotation. The wire is taken at the axis of rotation for the system. Now the mass is hung from right ends, but it is a known mass with no value. And this is what we've been asked to find for. So something very crucial here, you have to understand. 120 grams, the mass. Now what will be balancing? The balance is between the mass of the rods and the mass that is placed at its end to the right. Now that is definitely that is going to balance. Now the distance that we took here is the distance from the axis of rotation to where the mass is placed. The axis of rotation to where the mass is placed. Now if from here up to here is 65 and from point here to here is 8. Now from here up to here is what? 15. That is 8 minus 65. Wow. Now the distance from the mass of a rod to where the axis of rotation is placed is 15 centimeters. But also from here up to here to where the axis of rotation is placed is 8 centimeters. But the length of the whole rod is 1/3. Now from here up to here is equal to what? 1/3 minus 8, which is equal to 50 what? Now here it is 50 centimeters. Now the work is over. We take this one. We don't deal with this centimeter, 30 centimeter. We don't deal with them. But they are just there to help us to get the distance from the axis of rotation to where the mass is placed. The only distance that we deal is the distance from the axis of rotation to where the mass is placed. We don't deal with the other distance apart from that. Now, according to the principle of moment, the sum of anticlockwise moments is equal to the sum of clockwise moments. And the moment to the lefty, that is anticlockwise moments, is produced by 120. And here it is produced by x. Now in short, it is 120 gram times 15 centimeter is equal now to 50 centimeter times x or y. Now let us divide by 50 centimeter. Let us divide here by 50 centimeter. Now centimeter. By 5 here, 3. By 5 here, 10. By 10 here, 1. By 10 here, 12. Now we have 12 times 3, which is equal to 36 gram. Now the mass that will be hung to the right end is 36 gram. Now the question is over. The question is simple. But what makes it simple? You have the concept. Failure to understand the concept, you will be keep on lapping around and thinking the 65, 8, 130, and whatever the case it is. Now, from the principal moment, clockwise is equal to anti-clockwise moment, then we have seen it and I've written some. So I wrote these questions, I just wanted to see you. Now, a uniform half metal loop. I told you every statement have got its meaning. Every statement have got its what? Meaning. So, whenever you are dealing with these questions, you have to know a uniform half metal loop is freely pivoted at the 15 centimeters. Half metal loop, it is half. Now, it is just moving from here up to here. If it is half metal loop, that is 50 centimeters. Is it so?
Yes.
Now, from here up to 50 centimeters. Now, it is pivoted. It is pivoted at it is what? 15 centimeter mark. Now, the point of pivotation, it is at 15 centimeter mark. Now it is from 0 up to 15. Let's say here it is 15. Means from here up to here, it is 15 centimeter. That is the first statement. A uniform half metal loop is freely pivoted at the 15 centimeter mark. And it balances horizontally when a body of 40 grams is hung from the 2 centimeter mark. It balances horizontally It balances horizontally when a body of 40 grams is hung from the 2 centimeter mark. Now, it is still here. Now, we have seen from here up to here is 15 centimeters. Now, we've been told 40 grams is hung. Now, it is hung right here. Let's say there is the 40 gram right here. 40 gram right here. Now, from here up to here is 2 centimeters. Means from 0 up to where the mass is placed, which is 40 grams, is 2 centimeters. And from here up to where the pivot is
15 centimeters.
It is what? 15 centimeters. Now, we've been told to find out, draw the clear diagram of the arrangements. Now, this is no longer a clear diagram because you have not written the distance from the pivot to where the mass of the body, the mass is placed. Do you understand? Now, from here up to here, we have to know. But also, we are balancing between, there is a balance between the mass, which is 40 grams, which is placed to the left-hand side of the pivot. And it is balancing, it is the balance between 40 grams and the mass of the ruler. But remember, the mass of any uniform load, we said it is concentrated at its midpoints. Now, the midpoint of this 50 centimeter is 25. Do you understand? Yes. Now, from here up to here, let's say it is 25. Now, this is the midpoint of the ruler. Now, from here up to here is 25. Now, the mass of the ruler is hung from here. This is X. Because that is the second question. Calculate the mass of the ruler. I've been telling you, the mass of the uniform body is always concentrated at its center. And that's why we say the center of mass for the uniform body is at its midpoint. Now, the mass of the ruler is hung at its what? Midpoint. Now, from here up to here is 25. And from here up to here is 25. Now, definitely the distance that we always deal with is the distance from the pivot to where the mass is placed. As you can see, if from here up to here is 25, from here up to here is 25 centimeters. And then here it is 25 centimeters. But we are not interested with this distance and this distance. We are interested, the distance that we are interested with is the distance from the axis of rotation to where the mass of the body is placed. Now, if we are up to here is 25 and here up to here is 15. Now, from here up to here is what? 25 minus 15 is equal to what?
10.
Now, here it is 10 centimeters. But also from here up to here is 15 and from here up to here is 2. Now, from here up to here is what? Now, 15 minus 2, which is equal to 13 what? Centimeters. Now, this is a clear diagram. Now, at the end of the day, now you have this diagram. You have this diagram. Now, here is a pivot. Now, this one. Now, the clear diagram from here is this one. Now, we have this mass, which now is equal to 40. Here it is 40 grams. The distance from the pivot, it is 13 centimeters. And now here we have X gram. The distance from the pivot is 10 centimeters. Now that's all about comparison. The sum of clockwise moment is equal to the sum of anticlockwise moment. Now a moment is obtained by taking the first times what? Distance. Now here we have 40 grams times 13 centimeters is equal now to 10 centimeters times X. You understand? Yeah. Then we divide it by 10 centimeters. We divide here by 10 centimeters. Now X is equal now centimeter, 10, 10. 4 times 13, which is equal to what? It is 2, then 52 grams. Now the mass of the ruler is equal to 52 grams. That's over. You don't need to bother yourself. Now what we've been looking for, we've been looking for the mass of the ruler by considering that any mass of the uniform body is always concentrated to its center. That's the points that you have to note. And that's why here we have written X here as a gram because definitely this is concentrated at its what? At its center. Now after that, now this is the clear diagram for the arrangement and this is the correct answer.